Hey, how you doing? Okay, thank you so much for tuning in. There are two parts of this introduction to atomic structure, and I just wanted to break it into two smaller pieces so that it's a little easier to digest. So before we get started, if you want to make this really worthwhile, make sure that you've got your notebook open and you're ready to jot down some notes. Okay, so I'll try to make it clear when you need to write something down. Okay, so first, just to kind of get you oriented, before we talk about atomic structure, I know you know that this is a periodic table, and this is a way of organizing all of the elements that are known to exist, starting with hydrogen up here, and then way over here is helium, and so on. And so this is a periodic table of the elements. All right, so these are the the purest substances. Back when we talked about classifying matter, as you got to more and more pure substance, pure substances, you would eventually get down to the level of the elements. Okay, elements. What are elements composed of at their at the smallest unit? That's right, atoms. Okay, so elements are composed of atoms. So for example, let's look at here Cu, copper. If you had a little piece of copper in your hand, that is a collection of copper atoms that are held together by chemical bonds. And if you took that piece of copper and you started cutting it in half, like over and over and over again, all right, so you kept cutting it into smaller and smaller pieces, eventually you're going to get down to a point where you can't divide it any further without that copper completely losing its identity. All right, and so atoms are the smallest particle of an element that maintains its chemical identity. Right, so that's just to kind of set the stage. Now, what do we mean by chemical identity? Well, in a very cartoonish fashion, all right. This is just sort of a cartoon model of an atom, but it gets the point across. Let's imagine if you use your imagination and just pretend that this is one atom of iron. Okay, so we've taken a piece of iron and we kept cutting it into smaller and smaller pieces, and finally we got down to this single atom. That's as far as you can go. If you still want to call this iron, because if you split the atom, which is a process called fission, nuclear fission, then what you get are two smaller atoms, and they are no longer iron. You have fundamentally changed the identity of that element, and now it's no longer iron. Okay, so I just want you to know there's a limit to how far you can subdivide. Okay, so now let's get into atomic structure formally. So first, we need to establish what are the building blocks of atoms, and we refer to those building blocks as subatomic particles, right? Because they're one level under the level of the atom, and so we can. Here's my key. I'm going to use a reddish, circle to symbolize proton, blue for neutron, black for electron. And as you probably remember, protons, do you remember what the charge is on a proton? That's right. It's positively charged. What's the charge on a neutron? Hopefully you said no charge or zero, and that's true. Neutrons have no electrostatic charge, and electrons have a negative charge. All right, so these are the three subatomic particles that we'll be dealing with in chemistry this year. Just so you know, and you'll read about this in your book, electrons have a much, much smaller mass than the proton or the neutron. Okay, so electrons, these are little boogers compared to the proton and the neutron. Protons and neutrons are just about equal in terms of size and mass. All right, so hey, let's make hydrogen. So we're going to pretend that we're sort of masters of the universe, and we have this, like at a fast food restaurant, we've got these ingredients, these condiments that we can put together to make different atoms. So we got a pile of protons, a pile of neutrons, and of course a pile of electrons over here. So let's make hydrogen. Well, first, we don't want to just do this, helter-skelter. We need to follow the recipe. So we can consult the periodic table, and as you know, hydrogen's right here. And so when we quote unquote look at the recipe for making hydrogen, when we look at hydrogen on the periodic table, we notice it has a 1. This, it's this whole number. And what does that mean? What does the 1 mean? Well, hopefully from middle school science you remember that number, that whole number, is the atomic number. Okay, so formally that's known as the atomic number, and that tells you the number of protons contained in the nucleus of an atom of hydrogen. Okay, so atomic number is equivalent to the number of protons. Now back to the kitchen. Okay, so we clearly need 1 proton, right? So let's move a proton over here, and then we need one other. If we're going to make hydrogen and make it a complete atom, what do we need? What else do we need? So hopefully you're thinking, yeah, you're going to need 1 electron. Okay, and why? Well, because to have a complete atom, you need to have an equal number of protons and electrons. Okay, we want the charge to balance. So 1 positive and 1 negative add up to 0, which means that the atom as a whole is neutral. Okay, so for now, you may be thinking ahead and thinking, wait a minute, Dr. Hammer, I've heard there are these things called ions that have charges. Yes, that's true, but for right now, we're kind of building things up from the ground floor. We're going to be dealing with atoms that are neutral and have no net charge, which means you got to have the same number of protons as electrons. Okay? All right, so congratulations. We just made hydrogen. That's great. Oh, okay, so next, what about helium? Okay, so if somebody, customer comes by and says they want an atom of helium, what are we going to do? Well, again, you can go back. If you don't know the atomic number of helium off the top of your head, you can go to the periodic table, locate that, and it's way over here on the other side. And you can see that the atomic number is 2, which means that you're going to need 2 protons in the nucleus. All right, so let's bring another proton over. There we go. Are we done? No, of course not. You know that we now have an excess of positive charge, so we're going to need to bring an electron up here, and now we have a neutral charge again. Our charges are balanced between positive and negative. And so that's, when you make an atom of helium, you need 2 protons in the nucleus, and you need 2 electrons. Okay. Finally, let's just get crazy and let's just push all these protons up here. Okay, let's see what that does. All right, so now we have how many protons in the nucleus? Count them up. Okay, hopefully you see that there's 6. Therefore, we need 4 more electrons. Okay, so what element, what kind of atom did we just make? Well, okay, so you can peek at the periodic table. Which element has 6 protons in the nucleus? Okay, hopefully you zeroed in on the carbon, and you are exactly right. That would be a carbon atom. Okay, so that's it for this part. I'm going to we're going to pause here, and I'd like you to now look up the next part, which is part 2. What about the neutrons?